Welcome, dear students, to my channel Chemistry Knowledge. So here I have come up with another new video, that is solid state. This video I've specially made for class 12 board students, and in this chapter you are going to learn a complete analysis along with the board questions. So stay with me. This video is going to be very helpful and fruitful to you. So without wasting time, let's begin with the topics. Right? Now the first topic that we will discuss in this chapter is about the difference of crystal and amorphous. Got it? Now, crystal usually is something that has got a definite geometrical structure, okay? And amorphous is something which has a geometrical structure but it is not definite, okay? Now, if I have to show you the video or the figure of crystal and amorphous, then focus in these two figures. Got it? Now check here, see. This is the structure of crystal and this is the structure of amorphous. Why? See, here you have a definite and regular pattern. See, 1, 2, 3, 4. Even 1, 2, 3, 4. 1, 2, 3, 4. In middle you have this pink color 1, 2, 3, 1, 2, 3, 1, 2. So there is a definite pattern in this structure. Definite pattern of the atoms, molecules, right? Now, if you move on to this part, then what will happen is, say, there is 1, 2, 3, here is 1, 2, 3. These are all, they are arranged, no doubt, but they are not arranged in a definite geometrical pattern. So, if they are arranged in this way, we will call them as crystal, and if they are arranged in this way, we will call them as amorphous. Not that something which shines is crystal, we say, right? It depends upon the geometrical pattern, not on the shining pattern. Shiny is just one of the property of crystal. Got it? Now what you will do is, since I have already written here, like you will learn at least two difference between crystal and amorphous for your board exams, okay? Now one more thing I would like to highlight here, that is this chapter will give you 5 marks plus minus, not minus rather, it is plus 2 or sometimes it may go up to 7 marks, okay? So what you have to do is you cannot neglect this chapter, okay? And this is a very easy chapter. Be with me in this channel, you will understand entire things in detail by the end of this video. Now the main chapter is focused on crystal, okay? Now when we are learning about crystal, first of all we need to know what are the different types of crystal that we have, okay? Now this is only for your information. So normally we have 7 different types of crystal. You just need to know it, okay? You don't have to like learn or mug up entire thing. Now you may ask me, sir, what are the different types? Then the different types of crystal are the 7 different types of crystals. Here I am showing you. One is cubic, okay? Number 2 is tetragonal. Number 3 is orthorhombic, monoclinic, triclinic, rhombohedral, and hexagonal. So these are the 7 different types of crystal structure that you should be knowing, okay? Now one will be a length, okay, one will be a breadth, and this you can consider as breadth, and this you can consider as height, okay? That is all up to you. So you can label them as A, B and C, but better here it is. Now you may think, so why it is given A and A? Then the answer is very obvious. Yes, student, anyone? Yes, the length, the breadth and the height. So the length, okay, the breadth and the height, they are equal. That's why the same symbol. But here come to orthorhombic, the length, see, this side, this and this, they are not equal. That's why A, B and C. Here A and A, because two sides are equal but one is not equal. Are you understanding? So if you look at cubic, tetragonal, or if you look at all these 7 different crystals, then either the sides will not match or the angles between these sides will not match. Am I clear? That is why we have this 7 different types of structure, okay? You may refer further in your book also, it is given there. From there you will get a very good idea. Now let's come to the main part, that is unit cell. Now when we talk about unit cell, how to make it more easy to understand? See, look at the definition. Unit cell is the smallest repeating unit. That means suppose I have to make a big what I call it, I have to make a big cube, okay? I have one in my slide, I'll show it to you. Suppose I want to make a big cube, right? What I say, I want to draw this big cube. Okay, big cube. If you see properly in this big cube, it is consisting of small cubes, like say here 1, 2, 3, 4, at the top 5, 6, 7, 8. Now we can clearly see that this big cubic structure is actually made up of 8 small cubes. 1, 2, 3, 4, like this. Got it? So what is this small structure known as? This is a unit cell. Am I clear? And this structure is repeated in this direction, this down direction. This entire space where this unit cell is made, this is known as the space lattice. Okay, let me come back. This is known as the space lattice. Okay, so you have a small structure, it will repeat in this side, okay, and top side. All this space where you are repeating the unit cell, this space is known as the space lattice, and this small unit is known as the unit cell. Very simple. Okay, now what are the types of unit cell we have? Then for class 12 we need to understand these 3 different types. That is simple unit cell. Okay, sometimes we call it as simple cell also. Number 2 is the face centered unit cell, we call it as FCC. Okay, and next one is the body centered, so we call it as the BCC. Got it? Now I have shown you one figure here, so you can, it is very clear and obvious. From here only you will understand. See, primitive, that means simple. Simple means the atoms are present only at the corners. Check this. Body centered means the atom is present at the corner along with the body. See, one more you can observe here. Okay. And next, face centered means atoms are present at the corner, but they are present at the 6 different faces also. Am I clear? So body centered means inside the body, so one more, and in face centered you have in the corner along as in 6 different faces. Okay. Now let's understand what is the contribution of atom. Okay, what is the contribution of atom that is present, okay, in a not in a simple cube, rather. First of all, we will not understand in a simple cube. There's a small mistake here. What is the contribution of atom that is at the, first of all we will learn about the corner. Okay, suppose an atom is present at the corner, then what will be its contribution means how many more unit cell it can touch. This is the general idea. Okay, now come here, see, let me consider about this. Okay, if you consider this, not that one exactly, let's take this one. Okay, this atom. Now you tell me how many unit cell it is touching. Then this is touching this unit cell, this unit cell, this unit cell, this unit cell. 4 below, 4 above also, no? This one, 1, 2, 3 and 4. That means one atom which is present at the corner can touch 8 unit cells. Am I clear to you? Please focus on the figure and try to analyze properly. Okay, it needs little bit visualization for you. Now that means if the atom is present at the corner, then it can touch 8 unit cell. Okay, now one formula we will make here. See, how many corners will be there? How many corners will be there? 1, 2, 3, 4, 5, 6, 7, 8. 8 corners. And each atom at the corner can touch how many unit cell? Just now I explained you, 8. That means the formula says that there are 8 atoms in the corner. Okay, and each atom at the corner can touch how many unit cells? 8. So what is the contribution of? It is 1. That means the contribution of atom present at the corner is 1. Am I clear? Okay. Now suppose if it is face centered, then the atom is present at the corner along with the face, but we are not talking about the corner contribution here. We are only talking about the face, not face centered cube. Actually it is the face. Okay, face contribution. It will be only the body contribution. Okay, not body centered. We will come to this afterwards. Now how many faces will be there? 6 faces in a cube. Okay, and each face, now imagine how many unit cell can touch one face. Now let me give you an example. Okay, see, consider one atom that is present at this face. Okay, now this atom will be touched by this face inside and one more face outside. Am I clear? Am I clear to all of you? Imagine this somewhere where I'll choose somewhere here. Imagine this is the face. That means this atom is touched by this along with this unit cell. Understood? That means if the atoms are present at the face, then it will be shared or touched by 2 unit cells. So what will be the contribution? It will be 3. Okay. Now in case of body, see, body there is only one, and each will be touching one only, because if any element is present inside the body, no one else can touch. Okay, only that unit cell where it is present, that only can touch. Okay, that means the contribution for this is 1. Am I clear? So once again I am showing you the slides. If the atoms are present at the corner, 8 into 1 by 8. If the atoms are present at the face, 6 into 1 by 2, that means 3. And if atom is present at the body, 1 into 1 over 1, that is 1. Okay. Now we come to the main part, that is total number of atom in a unit cell. That means you have a unit cell. How many types of unit cell I have discussed? I have discussed with you simple cube, FCC and BCC. Now we will find what are the total number of atoms that is present in a unit cell. Now let's come back to the imagination. Come to simple cube. Where are the atoms present? Only at the corner. What was the contribution of the corner? 1. That means the total number of atoms present in a simple cube is just 1. Okay. Come to FCC. Where are the atoms present? It is present at the corner along with the face. Okay. What is the contribution of corner? 1. What is the contribution of face? 3. What is the total number of atoms? 4. Understood? That means the total number of atoms of FCC is 4. Okay. Come to body center. Where are the atoms present? Corner plus body. Contribution of corner 1. Contribution of body 1. Total number of atoms 2. So this is the formula you have to remember. Simple cube 1 atom, FCC 4 atom, and BCC 2 atoms. Clear? Now here comes one question for you. See, you have to imagine a unit cell. Okay, you have to imagine a unit cell. Let me take this unit cell. Now in this unit cell, see, A atoms are present at the corner. So that means all corners you are having A atoms. Okay, so I'll write here A, and B atoms are present at the face. So in the 6 faces you will have B atoms. Okay. Now there are 6. What is the formula of the compound? This is very easy. Let us come to A. Where is A present? Corner. What is the contribution of corner, students? Just now we have learned. Yes, it is 1. Got it? Come to B. Where is B present? Face. What is the contribution of face? 3. I am not talking about the total number of atoms. I am talking about the contribution. The contribution of A is 1 and the contribution of B is 3. So what is the formula? A, B, 3. Got it? So in this way you have to write the formula of the compounds. Now, a relation between D, A and R. Now what is D? D means the inter-ionic distance, means distance between the nearest ion. Okay. What is A? A means the edge length. So this, let me draw this length, that is the edge length. This is A. Okay. And if I consider only this portion, this is the radius R, which is present here. And what is D? D means the inter-ionic distance. That means this only. So this is a simple cube I have shown. That's why here D and A will be equal. But suppose if it is a BCC, body center, then one more atom will come in the body like this. That time, the nearest one for this will not be this, but it will be this. So this becomes here D that time. Am I clear? So D changes along with the change in unit cell. Okay. But since it is a simple cube here, so D and A is equal. I hope I am clear to all of you. Now this is a very important table which you all need to remember. Okay. Now one thing I would like to tell you, so I see this symbol is nothing but this is square root. Okay. Since I was not finding the symbol in my tablet, so I have used this. So like here, see, D is equal to A divided by root 2. In the same way it is D is equal to root 3A divided by 2 and R is equal to root 3A divided by 4. Please make the necessary changes, and I request all of you to take a screenshot of this, because this is very helpful for you solving the questions and understanding some of the topics. I hope I am going too fast for you, but I am trying to make my video as small as possible so that you will get the maximum knowledge in a limited time period. Okay, so if you want me to go slow, you can please comment me in my video afterwards, so that in the next coming videos I will teach you slowly. Okay, I hope still, but I'm going slow and I'm trying to explain you. Now next comes the packing fraction. Okay, now packing fraction, packing efficiency, it is something related to the structure, how compact the structure is. Okay, so we have learned about 3 types of unit cell. That is why we will learn about the packing also in 3 type of unit cell. Okay, now packing fraction is given by volume occupied by atoms divided by volume of unit cell. Okay, now when we talk about atoms, then what we'll do is atoms we will consider as spheres. See, it is like a sphere. So what is the volume of sphere? It is 4 by 3 pi r cube. Got it? And volume of a unit cell, say unit cell, it is a cube. There is a cube here. What is the volume of cube? It is side cube. Now what I have to do is I will divide this with a cube. Okay, 4 by 3 pi r cube divided by a cube. Now see, this parameters you can solve it. Take a screenshot. Only the factor is, so there is r and there is a cube out here. Okay, now we have to make it similar. How we will make it similar? Oh, see, one thing I'll tell you, this we are doing for simple cube. Okay, we are doing for simple cube. How to make it similar? Come to this. See, we will find a relation between r and a. What is r? R is equal to a by 2. That means what is a? A is equal to 2r. Got it? Let us apply this. What is a then? What we will get then? We will get 4 by 3 pi r cube by 2r whole cube. Got it? Why? Because a is equal to 2r. For what? For a simple cube. Now you do the needful, you open the bracket and you do the calculation. You will be getting 0.52. How much? 0.52. Now you multiply this 0.52 with 100, because we are finding the efficiency. Then you will get the efficiency of simple cube only 52%. Okay, that means a simple cube is only packed 52% out of its entire volume. See, in the same way you all can calculate for FCC and BCC. When you calculate the packing for FCC, you will get the highest, that is the 74%. Okay, and for BCC you will get it as 68%. So I request all my students to do the calculation and let me know and comment me in my video. Okay, if there is any problem, I will come with the solution afterwards. Now I hope this is the last topic for today in my video. Yes, okay. Now the last thing that we will learn is the density of solid. See, just now I said simple cube is packed only 52%. Okay, and FCC is packed how much? 74%. That means which one is more dense? Definitely simple cube. Yes? No. It is FCC is more packed. Why? Because its efficiency is more. So in order to find the density of solid, a very beautiful formula is given to you. You have to remember this formula. Now I'll tell you what is Z. Please note down in your copy. Okay, Z is the total number of atoms. Okay, what is M? M is the molecular mass. Okay. What is A cube? A cube is nothing but the edge length, but in centimeter. Make sure it is in centimeter. Okay, and what is this Na? Na is nothing but the Avogadro's number. Am I clear? So I request all my students to kindly take the screenshot of this, so that it will be easy for you to understand. Now one more question I'll be solving it for you, so that you will understand how to apply this formula in a better and a efficient way. Okay, now you have a structure that is PBS. Lead sulfide means it is the PBS. Okay, now all of you look at the question. Lead sulfide has how many? It has a face centered cube. Now let us come to the formula. Density is equal to Z into M divided by A cube into Na. Okay, Z means the total number of atoms. Now the hint is given here, face centered cube. What is the total number of atom in a face centered cube? In a face centered cube, the elements are present at the corner, the elements are present at the face. That means the total number of atom is 4. So 4 into M molecular mass PBS. So you have to add this to. So how much we are getting if you are adding this? You will be getting it as, how much you will be getting? You will be getting it as 239, 789, yes, 239. Okay, divided by A cube. Okay, now if you see here, A is given in pm. Now we have to convert this picometer into centimeter. So it will be equal to 10 to the power minus 10. Am I clear? So that means you will be getting 495 into 10 to the power minus 10 whole cube. Okay, into Avogadro's number is, all of you know this, 6.023 into 10 to the power 23. Am I clear? Now what will I do is, now see, after this I am leaving it up to you. You all can solve this. I'll just give a hint that you have this, see, 490, how much we are getting here? 495. Okay, so 495 into 10 to the power minus 10, you have to open the bracket. So what will be getting? 495 whole cube into 10 to the power minus 30. Okay, and you have here 10 to the power 23, that is coming from Avogadro's number. So you can rationalize this. Okay, so how much you will be getting? You will be getting 10 to the power minus 30, 23, so 7. Got it? So in this way, make it simple and try to solve and get the correct answer. And the answer for this, you all try on your own. The answer for this will be 12.708. okay, it is gram per cc. Why cc? Because we are doing the calculation in centimeter. Am I clear? So this is the answer which you all should be getting, and I hope all of you will get the correct answer. Okay, thank you dear students for watching my channel. If you like this video, please don't forget to subscribe my channel so that you get updated with all the latest videos, and you don't need to worry, you relax. I'm going to cover all the topics, okay, of your class 12. Got it? And share this video so that all other students who are not getting an opportunity to go to school, they also can get benefit from my channel. Thank you.